This is a 2013 Nissan Leaf battery module. You have seen it before. We are continuing on with our Nissan Leaf battery pack, battery module, battery cell series. And here's another one. And I have 5 more for a total of 8. There is a method to my madness. There is a reason why I bought 8 of these, and we'll get to that in a future video. But for now, what I like to do is measure the voltage of each one of these. We've learned in an earlier video that each one of these sardine cans is 8 volts. So if you think about it, this is less than a 9-volt battery. That's all the pressure, if you will. Voltage can be analogous to pressure. That's all the voltage this thing will have the potential of pushing, I guess. I know it's all about amps, but we're just going to keep it simple and focus on the voltage of these modules at this time. So here I have a multimeter, and this is pretty safe to work with at 8 volts. So you can use one of those cheapy Harbor Freight ones, what have you. But basically we set this on DC voltage, and now I'm going to measure the voltage of these modules to see where they sit. There's all sorts of rumors, and maybe there's some truth to that, that the Nissan Leaf battery packs, modules, degrade pretty quickly in their capacity. So, which makes them maybe no longer suited for EV applications, but they're great for other projects. They're great for solar systems. They're great for RVing and so on. So let's measure this. So this one here measures 805, 8 volts, 0.05. This one here measures 805. This one here measures 7.94. This one here measures 7.93. So this is what I'm getting at in this video. We're going to see if we can do something called balancing. If we can balance these modules, balance these cells, and we're going to use a method called poor man's balancing. Okay, we're going to see if we can poor man balance these modules. So the first thing I'm going to do is I'm going to measure once again all the voltages of these individual modules, and I'm going to actually write that down. And I may go as far as measuring the voltage of each of these cells. So this is 4.029, and then here it is 4.029. But if we take one of the lesser packs, this is 3.972, and obviously this one's going to be the same, 3.972. So you get the idea. They're not identical, okay? And that's why I want to balance them. That's why I want to try the poor man's method. So as I make these videos, I jokingly offer you top tips, and you can take them or leave them. Basically, don't be scared to label stuff. And these are permanent Sharpies, but are they really permanent? No, you can wash these off. And I rather just write on here than use like tape. You can print labels, you can do whatever you want, but I'm just saying go ahead and label it. So here we go. We're going to take this one again, 8.05. So the higher ones I'm going to make green because that's going to be sort of our goal, 8.05. Okay. And I know I just measured these, okay? I know I just measured these a few seconds ago. 8.05. But as my old coworker used to say, my memory is so bad I can hide my own Easter eggs. So, doing this again. 7.93. So in red, we'll do the other one, 7.93. Okay? And I think I'm going to start stacking them into two piles, the 805 pile and a 793 pile here. So let's keep measuring these. And this is repetitive, but we want to embed in our heads that these are 8-volt. This is what I call 8-volt. Okay, we're not talking about hundreds of voltages here. Yes, 48 of these will add up to about 360 nominal or something like that, because these end up running in a 96S configuration. And if we do the math on that, I'll post that later what that is, then that is going to be our full pack voltage. But these are very manageable. These are very attractive for hobbyists and guys who like to tinker, because we can pick these up. We don't need a hoist. They're light, they're maneuverable, they're safe to touch here. You know, there's nothing exposed. You could touch these. I wouldn't suggest it. You know, you don't want to do the tongue test on these like you do with 9-volt batteries. You get the idea. So these are fun to work with. That's why I'm playing with them. And I have a few projects coming up that maybe you'll be interested in. But for now, let's keep going. Okay, so we have 4 that are 805-ish and 4 that are 7.93-ish. Okay. Now, I didn't plan this, it just so happened, and I decided to make this video because I did take the volt measurements, and I was like, what the hell, they're not all the same. But this is a good opportunity to talk about doing the poor man's balancing. So just for funsies, I'm going to also write down the individual ones. So this is 4030. And obviously this side is going to be the same because these are in series here. 4030. In earlier videos, we discussed that there are 4 cells in here, and they are in a configuration called 2S, 2P. That means there's 2 in series, and then that series of 2 is parallel. So there's two of them, like 2 columns and 2 rows of them. So even although there's 4 cells times 4 volts will be 16 volts. But because we double up on them in their parallel configuration, it's only 2S, 2P, or 2 times 4 volts for a total of 8 volts. That's how we're getting these numbers. 3.968. And rather than re-explaining it and making those who suffered through my earlier videos a second time, if you haven't seen the prior videos, I suggest you just jump back and watch them, and you'll see how we came up with these numbers of 8 volts and 4 volts. 3.968. Okay, that's good enough for the girl's eye date. So now we move on to the next step. Okay, so to do the poor man balancing on these, we're going to use the buddy system. And for that, what we're going to do is we're going to put the low numbers down low or on the bottom, like so. So all these are the bottom ones, are the ones that are the weaker modules. And then we're going to put the other ones on top, the high numbers up high. I like to do those types of things just to help me remember. But these are labeled, but still you get the idea. Okay. All right, so I brought you in here closer so you can see what we're about to do next. So next what we're going to use is these bus bars. I think these are the OEM bus bars. The seller threw these in. I just went out and bought 8 modules. I didn't buy the whole pack, and they were only 25 bucks each. So for $200, I have 8 of them. And I asked him to throw in some of these. Top tip, whenever you buy, it's all about the power of negotiation. You don't have to be rude, but sometimes, when as a buyer, you might have some leverage. Sometimes as a seller, you might have some leverage. It all depends, but it doesn't hurt to ask. I mean, I asked him for the bus bars and he said, sure. Worst thing could have happened. He would have said, nope, I don't have them, or no, I'm not going to give them to you, or what have you. So we have these bus bars, and here I have some screws that will screw in there. These are not the ones from Nissan, okay? Time to show off my new toy. I got this as a present, so I am really happy with it and very thankful. And this allows us to take whatever fastener we have and see what it really is. I suspect this to be like maybe an M6, so 6mm by 1.0, and okay, that's what it is up here. I know you can go to like a hardware store like Home Depot or Lowe's in the States, and they have these in their hardware aisle, but gorillas force the wrong fasteners, either the bolt in the wrong hole or a nut on the wrong stud, and they are completely stripped. And I've fallen for that too many times that I don't play that anymore because I just don't trust it. So I got my own. This is high quality. I'm not affiliated with these guys. I'm not trying to sell you on this, but they are handy. Okay, so here's what we do. In order to balance these, we need to connect them plus to plus and negative to negative. Okay, so some of you might be screaming at this screen that I need to bolt these together. These do have these holes, which are on this pack, they're 5/16. I hear guys talk about using 1/4" all thread. Well, I did purchase some rods to tighten these, and once I stack them higher, I may tighten them down, but just for 2, I think we'll be fine, and so be it. Okay, I'm not going to bolt these down to compress them. It shouldn't be a big deal. And then we're just going to go like this. It's kind of hard here with the table. If these were hanging off the edge, it would be easier to do this. But I just want to show you what the general idea is. So this is positive to positive. And then we are going to do the same for the negative to negative, okay? This is basically doing a parallel connection. There's 2 kinds, and the third one is the hybrid of the 2. So these modules are actually in the hybrid configuration of doing both series connection and parallel connection. I don't want to confuse you guys too much, those of you who are new to the sport, but right now we're connecting these 2 modules in parallel. And if you don't remember which one is series and which one is parallel, I always tell myself parallel starts with the letter P, so it means connect positive to positive, P to P, P to P, and then the negatives just connect to each other just naturally. That's all you have left. So this is positive to positive, and then that dictates negative to negative. You can also connect these, okay? This isn't going to harm anything, and it may actually help us with the balancing. What I may do is connect 2 stacks with just 2 bus bars, so positive and negative, and then these 2 stacks with all 3 bus bars. so that it would be balancing not just 2 cells to 2 cells, but 4 cells to 4 cells. Okay, so let me go ahead and put the bus bars on the rest of them. All right, so I have the bus bars on here, finger tight, and now I'm going to go through and just snug them up. I don't think we need to use cheater bars on this. So you guys know the drill. This would be an opportune time to throw up some Chuck Norris jokes in the comments. And as I tighten these, what do you guys think happens to the voltage now? Each one of these modules is 8 volts. We've measured, okay, 805. So when we have 2 of them connected in parallel, what's happening to the voltage? Do a little review quiz here. What you guys think about that as I tighten the last 2 here? Do you think it doubled? Do you think it stayed the same? Well, let's bust out the multimeter. Not sure if you guys can see the numbers. Okay, so we're gonna measure here, just bus bar to bus bar, and it's measuring 801. So it's interesting, right? One of these is 805, but connected together, it's 801. Those electrons are running around, okay? So if we use the analogy of water, there's more pressure, water pressure in the top module than the bottom one, and that's forcing or sort of inviting the electrons to move from the higher charged module to the lower one. I noticed that these are smaller, so I think these may be like M4s or whatever you M&M people have. Maybe they're M5s. I'm gonna go get some random screws and see what screws in there and see how we can come up with maybe 2 joiny thingies for these 2. Okay, so we're gonna connect these 2 middle ones using my makeshift bus bars here that I just made out of some ring terminals with some metal wire in the middle there. Solid wire, I should say. Let's see, and these are 4 M&Ms instead of 6. I'm being told that the middle ones here are used primarily for BMS, not to carry the load. But internally, they seem to have as hefty of a bus bar internally to join the 4 cells as these terminals. Okay, so that's joined. Now we're going to do these. So for you young Padawans, whenever you're screwing something in, if it's more than 1 bolt, don't tighten it all the way, right? You want to leave it kind of loose and then come back and retighten it once you have the other one or the others in as well. There we have it. 8 modules, 4 stacks of 2 in parallel, and there's really one way to connect battery cells in parallel. That's on the cell level. Here we're doing it on module level, but as close to cell level as possible. And then the third way would be to put 2 whole battery packs in parallel, which is probably the least best way to do it, the least favorable way to do it. Anyway, and now I'm going to go for a walk, and you guys keep an eye on these, and we wait. I'll come back to these maybe in a couple hours, check on them, and then maybe do another video, see how they're doing. Okay, dudes, it has been approximately 4 hours, and now we're going to check voltage again and see if we have balance these cells if that's as long as it takes, or if we need to give it another day or week or whatever. So I'm putting this on volts DC. See if you can see that. Sorta-ish. So I'm actually going to remove the bus bars. Let's try that. Okay, well now they are completely disconnected, and we're going to try the top one. 8.01, and we're going to try the bottom one. 8.01. So it says 8.02, and I kind of let it settle for a second, and then it drops to 8.01, but both of them did that. So to me, it looks like they are balanced. Now, would I recommend you do this with one that is completely depleted and one that is completely fully charged and link those two together? Probably not. But we were pretty darn close. I mean, we were 805 versus 7.94. So I decided to risk it. So I'm pretty happy with that. I think they are balanced, and now we move on to whatever the heck I'm going to do in the next video. Thanks for watching, guys.